Hello everyone. Uh, Welcome to the 11th tutorial session of the network analysis course. So we have already done the 10 tutorial session last time on the topic of this two-port network. So we are starting the 11th tutorial session for the network analysis course, and the instructor of this course is Professor Tapas Kumar Bhattacharya sir from IIT Kharagpur. And I am Satvikram Pratap Singh, a PMRF research scholar here in Department of Energy Science Engineering, IIT Bombay. So we are starting with the first problem. So try to solve this and we will see if you are facing any doubt. Okay. Take your time to solve and let me give the H port parameter values simply how to write it. It is already given. If you see in the question that E1, I2 and I1, E2, it is already given H11, H12, H21, H22. And in this two-port network, you have to find out the value of H12, which is simply equal to I2 by E2 at I1 is equal to 0. Try to solve and get me the answer. Okay, let me give the solution for this problem. And if you see in this problem that few steps you have to remember for solving this kind of problem, that first step is you have to know the matrix basically. Here it is already given that for the H matrix it will be E1, I2 and H11, H12, H21, H22 and here is the I1, E2 basically. So step two is the if it is asked to find out the value of one single parameter, which is the case in this problem, that is asked that what is the value of H12. H12, if you see from the matrix itself, it is simply I2 by E2. Okay. At the value of I1 is equal to 0. It means that if you open circuit from the input side, okay. So if you open circuit this side, that is the input side basically, that is the input side. Okay. So the same voltage, this E1 will appear here. Okay. So it was being asked that what is the ratio of the E2, I2 by E2. So the I2 current, if you see here passing here, and it is get divided because there is no current here, I1 is equal to 0. So I2 when it is divided here, suppose this is I2 dash and here it is I2 double dash. So the same current will flow into this 2 ohm as well. That is the I2 double dash. Okay. It means that so they are connected in the parallel fashion. So equivalent circuit, how it will look like? It will look like something like this. Okay. This is the E2 and this is the I2 current which is flowing here. And this is the 2 ohm and this is 4 ohm. This is the 2 ohm and this is 2 ohm. And here it is open circuited. Okay. So if you see that this network, this and this, they are in the parallel. So equivalently, you can say that it will come out to be 4 ohm, and this is also a 4 ohm, 2 ohm, 2 ohm in series. So equivalent, it will come out to be 2 ohm. Okay, and this is already it is 2 ohm, and here it is E2, and the I2 current is injecting it. Okay, so simply you can say that E2 is equal to I2 times of 4, or you can say that I2 by E2 ratio will be equal to 1 by 4, which will come out to be 0.25. Okay. So it is basically the inverse of the impedance from the output side when it is considered the open circuit from the input side. So it is the ratio of the I2 by E2 at I1 is equal to 0. Okay. So the current answer will be the fourth option, that is 0.25. Okay. Let's move to the second problem. Try to solve this. Here in this problem, simply it is written that this is the R input, Ri, and this is the Vi, the V input, and this is the A times of Vi, and this is R naught. Okay, and the Ri is already given. Ri is given as 1 mega ohm. R naught is given as 10 ohm. Okay, A is the amplification factor, which is given as 10 to the power 6 divided by V, and V input is given as 1 microvolt. Okay, it is being asked the output voltage. Simply, this is the output voltage here, and the R input Ri. Okay, and the second thing it is asking that the what is the R output, the R input and R output. Okay, R input will be seen from this side, that is the R input, and the R output will be seen from this side, that will be the R output. Try to solve this. So in this problem, let me give the solution for this. For this problem, when you see, let me remove this. So if you see that it is asked that okay, what is the output voltage and the input impedance, output voltage, what is the input impedance basically, and the Z output impedance. If you find out the V output value, if it is open circuited from the input side, if you see that there is no connected circuit, so it is open circuited basically, and also the for finding out the value of V output, that is VTH basically. So the V input is basically amplified and its value became equal to the A times of V input. So if the output side is open circuited, so there will be no current. That is the I which is flowing in this circuit will become zero. Okay. So the simply the V output which will come out here, it will be simply equal to A times of VI. So A is already given, that is 10 power 6 V by V, and multiplied by 1 micro volt, that is 10 power minus E, it will come out to be 1 volt. Okay. So the A, B, C option is correctly matching. If you see the Z input side voltage, that is simply equal to the, if you see here, it is already open circuited. Input side, it is already open circuited, so there will be no current. No current means it's a infinite impedance is there. Okay. So it means that input side, if it is a open circuited, so the impedance which can be seen from the input side, it is infinite. Okay. So the correctly matching option is correctly A. Okay. Let's see that what is the value of Z output. If you see the Z output is simply the ZTH. For the finding out the value of the ZTH or seeing the impedance from the output side, you just have to short circuit the input side, input voltage. If you short circuit, suppose I'm short circuiting here, then there will be no voltage VI. Okay. So it means that AVI also becomes zero, and the simply the J output will become R naught. That is simply equal to the 10 ohms. Okay. So the correctly A option is correctly matching. Okay. Let me give the another problem. Try to solve this. And this is a good question, and there is a one hint I wanted to give in this problem. One hint that if you are having the input impedance, which I have told in the previous course also, that if there is a matrix here and I am adding some input impedance here, suppose this is a Z matrix, initially it was there, and I am adding one series impedance 10 ohm, then the Z new will become, suppose this is the Z old, so the Z new will become Z11. Suppose this Z old matrix is Z11, Z12, Z21, Z22. Okay. So it will become whatever the series impedance you are adding, it will be added to the first element basically. Yeah, that's correct. Z11 plus 10 and Z12 and Z21, Z22. Okay. So this is the hint, and also one more hint that for finding out the maximum power, if you remember the maximum power transfer theorem, you just wanted have to find out the value of ZTH. Okay, and for finding out the ZTH, you have to open circuit the input voltage. Input voltage, whatever will be the input, not input voltage, you can say, you can just say that for finding out the ZCH, short circuit all the voltage sources, and open circuit the current sources if it is there. Okay. So there are two hints. Okay. So in here also in this problem, the load impedance you have to find out for finding out the maximum power transfer theorem. What you have to do, you have to find it out that this is the Y matrix. If you see, you have to convert into the Z matrix here, and then find out the Z new. and then put the value of V1, that is the 120 volt, is equal to 0, you will be able to find out the value of ZL. Okay, try to solve it, and after that I will give the solution. Okay, let me zoom a little bit. Okay, is it clear? Okay, fine. If you get stuck somewhere, just let me know. Okay, I will give the few hints and make you solve the problem. No, it will not come in the milliohms. Okay, let me give the solution. Okay, so it is a quite bit lengthy and also a good problem. Maybe it will come in the if it is think of the gate exam, it will maybe come uh, in the 2 marks or something. Okay, so it is a higher marks problem. So you have to give at least 3 minutes or something to solve this problem. Okay, and by this trick, it will be make it easy to solve in the 1 minute or something. Okay, so let me solve this. So the Y matrix we already have, which is given as 1 by 100, 2, -1, -1, 4 by 3 Siemens. Okay. So we already know that ki Z new matrix when you add it will become Z11 plus 10 times. Okay, plus 10. Okay. So we know the Y matrix, we have to find out the Z matrix. Okay, Z matrix, what is the value of Z matrix? It will be inverse of the Y matrix basically. Okay, let's try to find out the inverse of this. Inverse, when you have this, suppose you have this Y11, Y12, Y21, and Y21 and Y22. When you wanted to find out the value of Z inverse, you just have to find it out the 1 upon, suppose this is a Y matrix. So 1 upon mod of Y, okay, determinant of Y basically, and reverse the diagonal element Y22 and Y11, and off diagonal element keep it as same but make it as negative. Okay, it will like this. Okay. The same concept I will apply here. It means that when you find it out the Z inverse, it is simply 1 upon mod of Y, what is there, and Y22, the diagonal element. This diagonal element will get reversed and off diagonal elements will become negative of that. Okay, same value but negative. Okay, let's apply the same concept here. When you see what is the mod of this, it will become 1 upon 100, it is already there, and it will become 8 by 3 here and -1. Okay, and simply reversing the diagonal element. So here it will become 4 by 3, here will become 2, and off diagonal element just multiplying it negative with -1 and keeping this values as same. So what it will come out to be? It will come out to be 1 upon 100. How what it will become? 1 upon 100 multiplied by 5 by 3 simply. Okay, it will come out to be 1 by 20. So in the numerator it will come out to be 60 because it is 1 upon 60 basically. Okay, and inside it is simply 4 by 3, 1, 1, 2. Okay, multiply this 60 inside, it will become 80 here, 80 here, and 60 here, and 60 here, and 120 here. Okay, so what you have got? You have got the old Z old as simply 80, 60, 60, 120. Okay, and what you have done, you are just adding the 10 ohm resistance in between the voltage source and the Z old. So what you have to find out, the Z new will become simply 80. This element, it will get added with the 10. It will become 90, 60 here, and 120. So this is the Z new basically. Okay. So for finding out the ZTH, what I have told, you just have to open circuit the voltage source and short circuit the current source. Okay, current source. If there is no current source, then leave it. If it is a voltage source, then you have to short circuit. Okay, let's first what you have to do, you have to just, so this is the 120 volt here. Okay, so when you short circuit it, it will become 0. Okay, so simply the V what was there initially, it will become 0 here, and this is the V2 basically, which is equal to here Z11, Z new basically 60, 90, 60, 60, 120, and here it will be I1, I2. Okay, and also there is a one thing. If you see there is a load here. Okay, so the voltage which you applied here V2, it will be V2 will be simply will be equal to I2 ZL. Okay, getting my point. In the last class also I have told if it is an impedance is connected at the load side, okay, when you have this two-port network, So the voltage which is appearing here, it is if it is a current going into the system, it will simply will become V2 is equal to I, which is flowing here. Suppose this is I2 multiplied by R. Okay. So that same concept I am applying here. So now I have got the two equations. Okay. Basically three equations. Here I've got the one equation from here, second equation from here, third equation from here. Let's separate it and write it separately here. So the equation 1 says that 0 equal to 90 times of I1 plus 60 times of I2. Okay. Equation 2 says that it is simply equal to V2 is equal to 60 times of I1 plus 120 times of I2. And equation 3, okay, suppose this is equation 1, 2, and 3. Equation 3 says that V2 is equal to I2ZL. Okay. From first equation, if you see, you will get the value of I2, I1. I1 in terms of I2, it is simply will be equal to, I1 will be equal to minus times of 60 times of I2 divided by 90. Okay. Or you can say that minus 2 by 3 times of I2. Okay. Put the value, put the this equation 3, put the value of equation 1 and equation 3 in equation 2. Okay. So when you put it, it will become I2ZL equal to 60 times of I1. What is the value of I1? It is minus 2 by 3 times of I2. Okay. Plus 120 times of I2. When you rearrange, it will become I2 times of ZL equal to I2 120 minus, if you solve 3, it will become 40 here. So when you cancel out the I2 from both sides, the ZL will become 80 ohms. Okay, are you getting my point? So the best approach was to find out the value of the Z old by inversing the Y matrix, then finding the Z new by adding the series impedance. Then for finding out the Z Thevenin, the open circuit the voltage source or the short circuit the current source. Here the voltage source is there, so we have just open circuited here and keeping the value same similar to that. And the load side there is a impedance connected, so we have taken the V2 is equal to I2ZL. Then we have kept the all the values from the equation 3 and equation 1 to the equation 2. Then we have got the ZL as a ATO. Any doubt in this? Any doubt? If you're facing any doubt in solving this problem, okay, okay, try to solve it at your at home also. Okay, okay, no problem. Okay, try to solve it again at home. So it is a kind of a good problem. So here the three concept we have seen. First, finding out the value of Z new, finding out the value of the Z from the Y matrix, then finding the value of Z new if a series impedance is given, then seeing that if it a load is connected, so how to finding out the third equation from that load itself. Okay, try to solve this problem. ABCD, simply you can write it like this. V1 I1 is equal to ABCD, and here it will be V2 minus I2 here. Okay, option B. Actually, it is correct. Option B is correct. So here in this problem, it is already the matrix is already given. It is simply n0, 0x. Okay. So it is asked that okay, what is the value of x basically. So the x is simply is equal to I1 by minus I2 at V2 is equal to 0. Okay. It means that when you short circuit the output side, suppose I am short circuiting the output side, it is being asked what is the value of I1 by I2. Okay. When you see that, that is simply the system is like this. Okay. Suppose the dotted terminal is upper side. So the whatever coming into the dotted terminal, it will leave from the dotted terminal. So it is meaning that, so the I2 actual direction is simply like this. What the arrow I am drawing. Okay. But the I2 which is already given, it is reverse of that. It means that it is I2. Okay. So the by the transformation we already know that V1 by V2 is simply equal to N, and simply the I2 by I1 is equal to also equal to N. Okay. Or you can say that here the I2 by I1. Okay. But that I2 which is flowing out of that network, it should be out of that this circuit. Okay. But it is reverse of that. It means that the actual I2 is minus times of I2. Okay. But in the question it what is asking, it's a minus times of I1 by I2. So it will be equal to x will be equal to 1 upon n. Okay. So this is the correct value, that is a 1 by n. Okay. Any doubt? Okay, try to solve this problem. Little bit lengthy, but it is good to solve. Okay. And the Y matrix simply will look like something this. That is I1, I2 is equal to Y11, Y12, Y21, Y22, and it is equal to V1, V2. So this is the input and this is the output. Okay. Try to solve. If you get any of the correct value, just let me know. Either y11, y12, y21, or y22. Okay, y11 you have got 2, that is correct. Okay. Okay, let me solve. Are you solving? So that I can give some hint. It will be easier for you to solve. Okay. Okay. Let me give few of the hints. Okay. So in this type of problems, where the all the options, okay, coming similar manners. If you see the options, option one, that is y11. Okay, three options of the one value, one option is the other value. And also if you see the other option, there also the three options same value and one option other value. Okay. So if I will able to find it out the value, one value in this two, then we will able to eliminate. Okay. And also there is one observation here that this is a dependent source. Okay. This is the dependent source and it depend upon the V2. Okay. 3V2 is its value. If I able to solve or find out the parameters where the V2 becomes 0. Okay. If you see from the equations also, if you wanted to find out the value y11, okay, simply. So it will be I1 by V1 at V2 is equal to 0. Okay. And also similarly the fashion in similar manner y21. Y21 is I2 by V1 at V2 is equal to 0. So it means that these two values could be found it out easily by short circuiting the output side. Okay. So when you short circuit the output side here, if you short circuit here, this 1 ohm will not be come into picture and also this current source will also not come into picture. Why? Because the 3V2 will become 0. 0 current means it is open circuited. Okay. And here it is short circuited, so it means that there will be no current which is falling passing through the 1 ohm. All will go through the lowest resistance path. Okay. So let's find out the value of y11. Y11 is simply V1, the simpler circuit because it is also not there and this dependent source is also not there. So this 1 ohm and this 1 ohm will come into the parallel fashion. Okay, simply. Okay, because it is already V2 is short circuited. 1 ohm is not in picture, dependent source is not in picture. So the simply the circuit will look like something this. This is the 1 ohm and this is also 1 ohm. Okay. So, and also this is V1 and this is I1. Okay. So the V1 will become I1 and this is in the parallel, it will become 1 by 2, that is 0.5. So I1 by V1 simply will become 2. That is correct. That way Y11 is simply 2. Okay. Let's see the second part. Second part is that if you wanted to find out the value of Y21, Y21, if you able to, because 2 Y21 is same person, that is the short circuited here and this dependent source will also not come into the picture. Y21 y21 is I2 by V1 at V2 is equal to 0. Okay, what could be the circuit will look like? Circuit will look like simply like this: 1 ohm here, 1 ohm here, here it is short circuited and I2 is flowing like this. I2 is here. okay, and this is I1, and this is V1, okay. If you see that this V1 is equal to here. If you see that, okay, what is the value of I2 basically? I2 is simply negative of I1, and the current which is flowing, it will become 1 by 2. If you're able to see that, okay, are you getting my point? So simply that is the because the current division principle, the I1 is simply it will become half of because the equal resistances are there in the path. So here it will become I1 by 2, and here also it will become I1 by 2. So I2, I1 by 2, it is negative of that. So because they are in the reverse direction, so it will be I2 is equal to minus I1 by 2. And the V1, if you see, the V1 is equal to I1 by 2. Okay, because the I1 by 2 current will flow into the 1 ohm. Okay, so what is the ratio of the I2 by V1? I2 by V1 will be simply will become minus 1 by 2 divided by 1 by 2 is equal to minus 1. Okay, so we were able to find out the value of y11, that is 2, and the y21, that is minus 1. So 2 means this option can be correct, and this is the y we have got minus 1. So this could be, so because this was already eliminated. Okay, so what if we got the minus 1, so it means that option C is correct. Okay, getting my point, because here only the my minus 1 is there. Okay, so this is the easiest way to solve this problem. Okay, just you have to observe that if it is any dependent source is there, short circuit something. Okay, trying to go with the element wise. Okay, if you will be able to short circuit the output side, that is V2, that dependent source which is depending upon that voltage, so that is output voltage, it will also become zero. Okay, so let's move further. Let's try to solve the this problem. This is easier. This is the easier problem, but I have kept it for the practice purpose. Try to solve this. Okay, I got the answer as option 1. Okay, let me solve and see whether it is correct or not. Okay, So if you see, if I wanted to find out the value of Z11, Z11 simply equal to V1 by I1 at I2 is equal to 0. Okay, from the matrix itself. Okay, so it means that if I will be able to open circuit the output side. This is the I2 basically here. Will be the I2 and this is V2 and this is V1 and this is the I1. Okay, if I will be able to find it out, if I am open circuiting this side, so this is I2 is equal to 0, it means that there is no voltage drop across 3, okay, because the current is already 0. So the equivalent circuit will look something like this. So it will be 2 ohm here, 1 ohm here, and the 2 ohm here, and the 1 ohm here. Okay, this is the V1 and this is the I1. Okay, so we have to find out just the equivalent impedance. Okay, so that it will become 3 ohm, 3 ohm in the parallel of 1, it will become 3 multiplied by 1, 3 plus 3, that is the 3 by 4, and that is simply equal to 2 plus 3 by 4. It is simply will become 2.75. Okay, so the option A is actually correct. Okay, and I wanted to find out Z12, Z12 is simply equal to V1 by I2 at I1 is equal to 0. For finding out this value, I just have to open circuit the input side. Okay. If you open circuit the input side, this 3 will come into 3 will come here, and this is the 1, and it will come here. Okay. So it will become simply 3 by 4 plus 3 Z12 V1 by I2 at I1 is equal to 0. Okay. So you will be able to find it out from your side. Okay, by when you are open circuiting and you are finding the value of the V1. Okay, so the V1 will appear here. Okay, so let's move to this another problem. Okay, try to solve this. Here the important information that I have already told, that if the output port is terminated by RL, it means that V2 is simply equal to I2 times of RL. Okay, use that concept and get me the. And when you're seeing from the input port side, okay, here also there is a catch that when you're seeing, suppose this is the two port network and this is the V1 here and I1 here and this is the V2 and the I2 is coming into the system here. It is like this, okay. So it is saying that it is output side, the port 2 is actually terminated by the RL and the input impedance is being asked. Suppose when you are seeing from the input impedance, suppose like this. So the Thevenin being asked from the input side. Okay. In this case, what is the value of Zi? Zi simply will become V1 by I1. Okay. Try to solve. you face any difficulty, just let me know. Okay. Okay. I'm giving 3 minutes to go through this problem, and after that, I will solve it. Should I solve or you need time to solve? Okay. Just let me know. Okay, sure.
Here is the answer, the correct one.
Uh, you are giving answer or asking for the answer? Okay.
Option A is the
Okay,
correct answer.
option. Okay, okay. So I got one answer at the option A. Let's wait for a few more minutes. Let the other also to solve and re-verify whether it is correct or not. Okay, whatever the method you have taken, re-verify whether it is correct or not. Okay, so this is a very easy problem. Okay, from the statement or the answer, you can say that it is a looking difficult, but it is very easy. Okay, let me give the solution. When you see the equations, it is there. It is like this: V1 is equal to A times of V2 and minus B times of I2, and the I1 is equal to simply C times of V2 minus D times of I2. Okay. And what is being asked? It is asked that what is the value of Z input, that is basically equal to V1 by I1, V1 by I1, and given one hint that the output port is actually terminated by RL. So here if you see, it is terminated by one resistance, that is the RL. Okay. So the output I2 is coming into the two-port network, which is assumed to be positive.
Second option D, sir. D.
Okay, okay, let me solve that. After that, we will verify which is correct. Okay, try to see the procedure. Okay, that is more important. So if you are terminating with the value of the RL at the output side, so the simply it's a voltage, that is V2 will become minus times of I2 times of RL. Okay, and what we need simply V1 by I1 ratio. Okay, if you see the equation 1, this is the equation 1 and this is the equation 2. If you divide both, it is simply equal to V1 by I1 ratio, which we needed, that is equal to Zi, and it will become simply equal to A times of V2 minus B times of I2 divided by C times of V2 minus D times of I2. And what we have, if you see that here we are having the V2 by I2 ratio, that is simply equal to minus times of RL. Okay. If you divide the numerator with the I2 and the denominator also with the I2, you will simply get this. A is equal to V2 by I2 minus B divided by C V2 by I2 minus D. Okay. And we already know that V2 by I2 value is simply equal to RL minus RL. Let's put this value, let's put this value of the V2 by I2 here, that is V2 by I2. It will become A times of minus RL minus B divided by C times of minus RL minus D. So it will become B plus A times of RL plus divided by D plus C times of RL. So the option D will be the correct, okay? Not option A or not option B, okay? Any doubt in this? Any doubt? You just have to uh, take the ratio. How to get that value? What we know and what we wanted. We know that V2 by I2 ratio is simply equal to the minus RL. That is the hint which is already given. And the Z input we already know, that is equal to V1 by I1. And then we have taken directly the ratio and kept the value of the RL into that equation. Okay. Let's move further. Let's try to solve this. Try to solve this problem. Write the answer in the chat box. Okay. Any answer? If you got any value, Z12 or Z21, any value? Okay, Z12 as a odd number. That's correct. Try to find out the Z21. Okay, option D. Okay. Okay, let me solve and let's see whether it is correct or not. So Z12 will be simply equal to V1 by I2 at I1 is equal to 0. Okay. So it means that when you are, suppose it, suppose I am taking I1 is equal to 0. Okay. It means that the current source, because this is a dependent source, this is also a dependent source, so the beta I1 will become 0. If a current is 0, it means that the circuit is open circuited. So this circuit here, it is simply open circuited. Okay, there will be no current flowing. So equivalent circuit, how it will look like? It will look like something like here, and this will be open circuited. So here it is R0, and here it is I2, and this is the V2 basically, and this is the V1. This is okay. So if you see that what is the value of I2 here, so V2 will be simply equal to I2 times of R0, and the V1 is simply here, the I1 is already is equal to 0, so V1 is equal to 0. Okay, what is being asked that V1 if you see the V2 by R2. Okay, so it is already being seen that if the current is 0, if the current is 0, so the V1 which is appearing across this, it will be also become 0, no? Why? Because if you see the current is 0 here, the current which is flowing through the RE will also become 0. That is the I1 RE will become 0. Okay? So though the voltage which is appearing across it will already become 0. So the option D will not match. So the correct option will be option B or option C. Okay? Let's try to solve for the Z21. Z21 which you see, Z21 is V2 by I1 at I2 is equal to 0. It means that I2 I'm open circuiting here, this circuit. This is simply open circuited here. Okay, so the I2 is 0 here simply, and the V2 is it asked. Okay, so the V2 will be the current which is, suppose this is I2 here, there will be no current I2. So it means that beta I1 which is flowing here, it will simply flow in this loop. Okay, so the V2 will simply will become minus times of beta I1 because the current is in the reverse direction and the voltage is appearing like this, minus beta times of I1 times of R0. Or you can say that V2 is equal to minus I1 times of minus beta R naught. Or you can say that V2 by I1 is equal to minus beta R naught. So the correct answer will become, what will be the correct answer? Correct answer will be option B. Any doubt in this? Because in the Z12 also, Z12 which we have solved here, Z12 is simply equal to V1 by I2 at I1 is equal to 0. If you are keeping I1 is equal to 0, it means that the voltage which is appearing across the RE, it will become 0. It means that the V1 will also become 0. Any doubt in this? Okay, so the option B is correct. Okay, try to solve this. It is simple problem that try to find out the value of Y21 basically, Y21. Y21 will be equal to I2 by V1 when the V2 is equal to 0. Should I solve or you're solving? Okay. Are you still solving or should I give the answer of this? Or should I solve? Just let me know. Okay, let me give the solution. Okay. So it is being asked that what is the value of the Y21? Y21 simply equal to I2 by V1 when you are short circuiting the V2 side. Let's short circuit the V2 side. When you short circuit this V2 side, then the V2 is equal to 0. And try to write the equation because the I2 is flowing like this. So the current which is entering in the 4 ohm, it will be simply equal to I1 plus I2. Okay. So the V1 you can write it. Try to apply the KVL in this loop. You will see that V1 is equal to 2 times of I1, okay, plus 4 times of I1 plus I2 minus 8 times of V1, okay. So simply you can write it like this. 9 times of V1 is equal to 6 times of I1 plus 4 times of I2. This is the equation 1, okay. Now apply the KVL in this loop. It will be simply equal to, because the V2 is already 0, V2 will become equal to 0, 4 times of I1 plus I2 minus 8 times of V1. Okay, simply you can write it like this. 8 times of V1 is equal to 4 times of I1 plus 4 times of I2. Okay, that is simply the same equation, I think. Okay, 8 times of V1. That is simply the same equations which is coming. It is what is being asked. It is asked that I2 by V1. Okay, I2 by V1. Let's go through it. V2 is equal to 4 times of this, and it is equal to 2 times of I1 and 4 times of I1 plus I2 and minus 8 times of V1. Okay. So let's find out the value of Y21 at I2 by V1 basically. So I2 by V1, 4 times of I here, so 8 times of V1 here. Okay. So it means that they are coming nearly not equally equal. Okay. So the question is having some fault. Okay. So in this problem, there are the two equations when you are seeing that 9V1, 6 times of I1 here. Okay. You want to say something? Uh, you can open your mic and ask or say whatever you want. When you see the both equations, they are in the same manner that I1 and I2, they are non means if you see the multiple solutions can exist in the both equations. Okay. So that value of the Y21 cannot be find it out from these two equations. Okay. It and also if you apply the KVL in this loop also, the V1 is equal to 2 times of I1. That is simpler that the V2 is equal to 2 times of I1. But this the same equations are there in the both terms, but the values are different. Okay, if you see there 9 V1 and 8 V1 here. Okay, it means that multiple solutions can be possible, so it will give the incorrect answers. Okay, so the Y21 is not possible to calculate in this question. Try to solve this. Just simply find out the value of the V output, which is given here. That is the V output here, V output, and in terms of the VI. Okay, take 1-2 minutes and don't take much so that we can move further and see the op-amp problems also how to solve that inverting and non-inverting amplifiers. So in this problem, the V output by VI is already given that 1 upon 2 plus SCR. Okay, you just have to find it out that by finding out the equation how it is relating to this R. Okay, that's the value of the RL. Okay, let me solve and check whether it is correct or not. When you see that the RL and C they are in the parallel, so equivalent can be drawn like this. So this is the R, this is the V input here, and this will become the R equivalent of this, and there it is V output. Okay, so the equivalent will come out to be RL multiplied by 1 upon SC, because it could be represented in form of the S, that is 1 upon SC, divided by RL plus 1 upon SC. It will simply will become RL SC RL plus 1. Okay. If you see by the voltage division principle, the V output will be equal to, suppose this is the Z dash. So the V output will be simply equal to Z dash divided by Z dash plus R times of V input. Okay, by voltage division principle. Put the value, suppose this is also Z dash, put the value in the equations, it will become RL divided by 1 plus SCRL divided by R plus RL divided by 1 plus SCRL. Okay. When you solve it, it will become RL divided by R plus SCRL. Okay. SCRL R plus RL. Okay. In the numerator, if you see there is a 1, it means that you have to divide it by RL to make the numerator as 1. Okay. I'm solving here. Okay. When you divide the numerator and denominator by RL, it will become 1 divided by R plus RL by R plus SCRLR, or you can simply say that RL divided by RL. Okay. So here if you see, this is simply equal to 1 plus RL by R. Okay. Which is equal to 2. If you compare here, this is the 2 here, and this is equal to this 1 plus RL by R, because here it is coming SCR. Okay. So the 1 plus RL by R will be equal to 1, or 2 which is given here, that is 2. So the RL by R will be equal to 1. So the RL will become equal to R. Okay. Any doubt in this? Simply you have to make the transfer function and then compare whatever the values are given. Here the numerator is given 1, so you have to compare and making the transfer function numerator as 1. Okay. Any doubt? Okay. Let's move to the last problem of this kind of two-port network. Try to solve this. last 1 minute. Okay, don't take much time to solve this because we have already seen this kind of problem. Take 1 more minute to solve. Okay, let me give the solution. Are you trying or should I give? Okay, let me. Okay, take your time and solve. Okay, 10.4. Let me verify. Okay. So in this problem, what is asking that the value of the V is value will be given as V1 by minus I2 at V2 is equal to 0. It means that you have to short circuit the V2 side. Okay. When you short circuit this V2 side and write the equations, this is the I2 here. I2 will also flow here, and there the I1 is coming. So the what is going into this 5 ohm, that is I1 plus I2. Write the KVL in this loop. It will simply equal to V1 is equal to 2 times of I1 plus 5 times of I1 plus I2. It will be simply equal to 7 times of I1 plus 5 times of I2. Okay. And the V2, when you write, it will become 0 times of, because when you are applying the KVL in this loop, it will simply equal to 0, 2 times of I2 plus 5 times of I1 plus I2. Okay. Or you can write it like this. 2 times, or you can write it like this. 5 times of I1 plus 7 times of I2. What we need? We need the V1 by I2. It means that we have to put the value of the I1 in this equation to get the value of I2. Okay? Simply put the value V1 is equal to 7 times of I1. I1. So it means that it will be minus 7 times of I2 divided by 5 plus 5 times of I2. Okay? Let's solve. It will become I2 when you take a common minus 749 by 5. Okay? But it will come out to be, let's solve by calculator. 49 divided by 5, 49 divided by 5 minus, so it will come out to be minus 4.8. Okay, okay. So the answer, so the B value that is equal to V1 by minus I2, it will simply come out to be 4.8. That is correct. Okay, okay, that is correct. 4.8. Okay. So these are the point means variety of problems which can be come into the two-port network. Let's move to the one important topic where the theoretical question can be observed. This is the gyrator. Okay, gyrator is nothing but it is it can be represented in form of a transformer. If you have seen this transformer, transformer could be like this simply. Okay, so this is the V1 here, I1 entering here, and the I2 going out, and here it is V2. Okay, simply. Okay, so this is a kind of transformer. If you see like this is a similar manner the transformer could be represented. And these are the two equations which is important, which is being known as the for the gyrator equations, that V2 in terms of the I1, it means that the output voltage in terms of the input current, and input voltage in terms of the output current. Okay. So it is represented as V1 is equal to minus times of Ri2, and V2 is equal to R times of minus I1. R is simply known as the gyrator resistance. Okay. Theoretical part I have gave here. You can read it out, whatever this, how the discovery was made and who have invented and why it is important. The important part is that the voltage, the output voltage could be represented in form of the input current through this gyration resistance, and the input voltage in terms of the output current. Okay, simply equal to the, when you are representing output voltage, it is simply R. When you are representing input voltage, it is minus R. Okay, and this is simply that power is equal to 0 in this, because the V1 I1 plus V2 I2, when you put the value of the V1 in terms of the I2 I1, it will simply will become 0. And the Z input is simply equal to min R square divided by Z load. Z load means when you are connecting the load here, suppose this is the ZL I have connected. So the Z input simply will become R square by Z load. This derivation is already given by professor. You can see that lecture. But just remember that. And the question could be asked in this kind of problems, that suppose R is given. Suppose the R is given as 2 ohm, and ZL is given as 2 plus 3J. Okay, the question can be asked in this kind of problem, that what is the nature of Z in. Okay, so simply what you have to do that Z input is equal to R square. R is already given 2 square, that is the become 4, and divided by 2 plus 3J. Okay, try to find it out in terms of the mod of some magnitude, mod of Z in, and angle of something Z in. And if it is in negative, it means it is a capacitive nature. And if it is a positive, then it is an inductive nature. And if it is zero, then it is a kind of resistive network. Okay. So this is the one of the problem could be asked in this garage, and simply the properties I have already wrote. You can see the slide which I will share. Okay. The important concept here is the op-amp. Okay. There is a assignment problems in the 12 tutorial session tutorial assignment 12 assignment which is dependent upon the op-amp circuits. Okay. That op-amp circuit, that derivations you can read it out that this is the just amplifier. Just amplifier means whatever the input voltage you are giving, that is the could be amplified and getting the voltage. If you see here, this is the V positive, V negative here, and this is the suppose this is I have connected this R naught here. Okay, so the voltage which will appear here is the V positive minus V negative. Okay, why? Because this is just a voltage difference which will appear across the R naught, and it is amplified through this dependent source, which is equal. So this output will become A times of V positive minus V negative. Okay, whatever the voltage we are applying from the input side, it will get amplified with a gain of A, and it is equal to the it is multiplied with the difference what you applied from the input side. Okay. The second important point is that this op amp have the two voltages, that is the VCC and VEE, or you can simply sometimes it is written as VCC and minus VCC. Why is this important? I will show you in the lecture here. So there are two types of op amps, that is the inverting and non-inverting. How to check? How to know if it is a circuit is given, so whether it is an inverting or whether it is a non-inverting amplifier. There is a one trick. Trick is like when the input is connected at negative terminal, okay, the input voltage that the Vi is connected to the negative terminal, then it is inverting. Okay. When it is connected, the input voltage is connected to the positive side, then it is non-inverting. Okay, negative it is inverting, positive it is not inverting. Let's see from the examples itself. Suppose the circuit A, the V input is connected to the negative, so it is inverting. In the B, suppose we have seen the B, B is also the input is connected to the negative, so that is also inverting. When you see the C, the negative, the V input is connected to the negative, it means that it is inverting. Let's see the other questions also, other amplifier designs also. Here also the input is connected to the negative, it means that it is inverting. If you see the last this one, here the negative it is connected to the input here, so it is also inverting. Suppose I have take this example. If you see here, the input is connected to the positive, so it means that it is non-inverting. Here also, if you see in these two examples, either it is connected to the positive, the input, so that's why it is non-inverting. Here also the positive is connected to the Vs, so that is non-inverting. Okay. This is important point, that how to judge whether the op amp is negative, inverting or non-inverting. Second important thing is that finding out the value of V output. Okay. In the slides also, when you have seen the lectures also, this potential which is appearing across the positive side, it is reflected to here. Okay, that the internal architecture was simply like this, no? So this was the internal impedance R naught, this was the V positive, this was the V negative, and there is a one dependent voltage source which is amplifying this V positive negative. So V output will simply become V output V positive minus V negative. This is simply equal to the V output. Okay. So this R naught is simply in the mega ohms. Okay. That's why the current which is flowing into this network will become zero. Okay. Nearly equal to zero. So that's why the current which is coming from this side simply move from the RF and move to the output side. Okay. So it will not go into the op amp. So that's why the all current will flow like this. And also this V positive and V negative, they are simply equal. That's why the current will become zero. Okay. How the current will flow? Current is simply equal to V positive minus V negative divided by R naught. If the R naught is very high, the current is simply equal to 0, or you can say that V positive is nearly equal to V negative. Okay, so that's why remember this, that whatever the positive terminal voltage is there, just reflect to the other side, negative side, the node which is connected to the negative directly. Suppose here it is 0, so it will also become 0 here. Okay. Then you apply the KVL. Apply the KVL if it is a inverting, apply the KVL. How to apply KVL? KVL apply in this loop. Okay. For finding out the value of V naught. Okay. So the circuit simply equal to like this. R1 here, and this is already grounded. This is 0, and the V input is here, and the RF is connected like this. This is the RF, and here it is connected at this node, and this is the R naught here, and this is the V output, and here it is RL. Okay. Here the current will be there. Here the current will be there, but it is not non-zero. But the current which flowing into the minus and the positive, it is simply equal to 0. Okay. So if I apply the KVL in this KVL here, let me apply KVL here. Suppose this is node A, I have applied the KVL here. Suppose let's take that this is the Vx, okay, and this is the VA here. VA is simply equal to 0. Why? Because we have already reflected the positive value here in the negative terminal. So it will become 0 minus V input. Always assume that the current is leaving that node. So it will become 0 minus V input divided by R1 plus 0 minus Vx divided by Rf is equal to 0. Why? Because the current will not go here. Current will simply go here and here. And the negative terminal, I have assumed that the R naught is very high, so that's why the current will not go. Okay. So the Vx could be represented like this, that Rf minus times of Rf, R1, V input. Okay. So, and also when you finding out, suppose you wanted Vx, we already know, Vx we have got. What is the value of V output? V output will be simply equal to RL divided by RL plus R naught times of Vx. That is the voltage division principle. Or you can write it that RL divided by RL plus R naught multiplied by minus RF by R1 times of V input. So we have got the value, that the ratio of the V output divided by V input. Okay. Any doubt in this? If you have any doubt, just let me know. First thing, what you have to remember, how to check the inverting and non-inverting operational amplifier. Second thing is that gain is very high. When it is given that the gain is very high, it means that the current which is flowing into the negative terminal or the positive terminal is zero. So assume that the positive, whatever the voltage which is appearing at the positive, reflect it to the node which is connected to the negative. Okay, that's why we have positive connected to ground. So that's why we have kept the negative terminal also equal to 0. Then applied the KVL and solve the output in terms of the input. Okay, let's take the another example and see what is actually happening. Suppose I take this example. Okay, what I have told, whatever the positive voltage appearing, apply here. This will also become 0, and then apply KVL. Suppose I am applying the KCL here in this loop. Assume here it is V output already given. So when you apply the KCL here, so it will become 0 minus Vi divided by R1, because the current here I am assuming that it is out of that network, plus 0 time minus V output, because in this branch, what is the current? The voltage difference divided by current. V divided by RF is equal to 0, because the negative side there will be no current into the system. So V output will be simply equal to minus times of RF by RI R1 times of V input. Okay, that is the same answer we have got from the previous one. Okay, any doubt? You just have to apply the KVL at that particular node to get the value of the V output. Okay. If it is not directly given, they apply the voltage division principle to get the value of the V output. Let's see this another example. Suppose I'm taking this example here. Suppose this is the first part. If you see here, then how to find out the value of the ratio of the V output by V input? Okay. Here it is 0. So it means that I have also taken here also 0. Okay. Let's apply the KVL. 0 minus V input divided by R1 plus, if you see there is a two nodes because it is V output is not directly connected. So we have assumed that suppose this is the Vx. So we need the two equations. Another equation will become 0 minus Vx divided by R2 is equal to 0. Okay. Second equation, apply it here, Vx. So it will at node B. Suppose this is node A, node B. At node B, that is the Vx minus 0 divided by R2, because here at the node A it is 0 plus Vx minus V output divided by R4 plus, because the R3 branch is also there, so this is simply equal to Vx divided by R3 is equal to 0. Okay. Rearrange, it will become Vx 1 upon R2 plus 1 upon R4 plus 1 upon R3 is equal to V output divided by R4, or you can simply multiply it. So put the value of this Vx into this equation, you will get the relation between the V output by V input. Simply, okay? That is the easier way to solve this. Okay, let's take the another example. Suppose I am taking this simple example. Here also, this is 0. This is also become 0. Apply the KVL in this loop. So it will become 0 minus V input. So here also you can see that the V input is already becoming 0 here. Okay, because this node is already connected here. Okay, so if it is 0, okay, so the current which is flowing here in this loop, it will simply will become 0 minus V output divided by RF is equal to IF, getting a minus times of IF. So V output is simply equal to minus IF RF. Okay, and the V input is 0. Okay, getting my point. So in a few of the problems, it is not, some resistance will not be connected here, so you can directly assume that the V input is already being equal to 0. Let's take the example like this. Suppose this is the non-inverting amplifier. Here the positive, there is a no grounding sense. So how to solve this kind of problem? Suppose the grounding is not there, but the positive terminal is directly connected to V input. Okay. So that voltage you should reflect to the node which is connected to the negative side. So this is the V input. Apply the KVL. KVL, or you can say that apply the this. If you see this network, so the V input is simply equal to R1 divided by R1 plus RF times of V out. Okay, that is simply the voltage division principle, because the current which is going here is 0. Here also it is 0, which I have told that because here the internal impedance is very, very high. So that's why the current which is going into that node is 0. So the voltage which will be reflected is here, they will be simply reflected here. You just have to apply the voltage division here. Okay, let's take another example also. Let's take these two examples. Suppose I'm taking this example. In this problem, if you see, here V input is here, okay? Here the node, this is also V input. Reflect it here, V input here will become here. So that is the simple. And V output is not directly connected. So it means that suppose this is the, assuming that this is the Vx, okay? Getting. So the Vx will be, the V input will be equal to simply voltage division principle, that is R1 divided by R1 plus RF. And the V output is simply equal to, V output is equal to current which is flowing here. So V output will be equal to Vx plus, suppose the I current is flowing here. This is simply equal to I times of R naught. Okay, getting my point? So that's the way to solve this kind of problems. The in tutorial in the assignment also, that is simply you have to use this concept. In this problem, if you see here, the Vs, because we have assumed that the current here will become zero, so there is no voltage drop in the Rs. So this voltage here at this node will be reflected simply, which is connected to the positive, that is simply Vs. So you have to connect here also, this will also become Vs. This is also Vs, so this will become also Vs. So this is also connected to this node, so V output will be simply equal to Vs. So this is called as voltage follower circuit. Voltage follower circuit, which always follow the input voltage. That is simply equal to the output voltage simply equal to the Vs. And its gain is simply equal to V output by V input, and here it is 1. Okay, are you getting my point? So these are the method to actually calculate the value of the V output, or you just have to simply apply the KCL at that particular node or voltage division principle, you can solve it. Okay. So that's all for the today's session, and we will solve the few of the problems of the op-amp in the next tutorial session. Okay. Any doubt till here? Okay. Thank you for joining and have a good day.